So, how far behind are we now?
Oh, well, we finished the electrical today, so now we're only 3 days behind.
It doesn't look finished.
Yeah, well, we still need to do the outlets, but it's hot now. I mean, not right now. It's shut off, but we tested it. And...
Just tell me this. When am I actually going to be able to plug in a lamp?
Oh, not long at all. Well, we've got to do the drywall first, but then... Soren!
Electricity is a serious workplace hazard, and hundreds of people die each year because of shocks, including related injuries like burns and falls and electrical fires. Of course, it's not just workers that suffer. It's friends and families, too. Engineers, electricians, and other professionals work with electricity directly while working on overhead lines, circuit boxes, and wiring. Office workers and salespeople work with electricity indirectly when they use things like appliances, computers, or power strips. Whatever work you do, you have the right to electrical safety. But no matter how safe your employers make your workspace, you have to do your part by understanding basic hazards and safe practices and using good judgment and caution.
Soren! What is it? The frame? Oh, no, the wires. They're hot. But someone's here? They must have turned on the power. He's locked in a circuit from the wires to the metal frame.
Understanding electrical circuits, conductors, insulators, and grounds will help you recognize electrical hazards in the workplace. Select each button to learn more. Electricity is the movement of electrons. The flow of electricity is called current, and it travels in a path called a circuit. In the electrical situations you encounter on the job, current in a circuit flows out from and back to its power source. Typical power sources are breaker boxes or power outlets. Electrical current needs something physical to travel through. This is called a conductor, like copper wire that you find in a house or in an extension cord. Many metals like aluminum and steel are good conductors. It's important to note that conductors can heat up or spark when too much electricity passes through them. The human body is a good conductor too, especially when your skin is wet or sweaty. Electricity doesn't travel well through insulators, materials like rubber, plastic, and glass. The casing on wires, the soles of your boots, plastic tool handles, and glass insulators on power lines are all insulators that resist the flow of electricity. Wood is a good insulator if it's dry, but not if it's wet from water or heavy treatment. Electricity naturally travels to the earth, literally the ground. At work, a ground is a safety feature that diverts an electrical system's current safely to the ground and rapidly trips the circuit breaker, shuts off the electrical flow, to remove the electrical charge from the circuit, protecting the circuit and the workers near it. A ground is often a steel frame of an appliance, copper pipes in a house, or a metal rod buried in the dirt at a breaker box. Read the following description of an incident and then select Continue. How did this accident happen? Select the best answer, then select Check My Answer. Read the following description of an incident and then select Continue. How did this accident happen? Select the best answer, then select Check My Answer. Read the following description of an incident and then select Continue. How did this accident happen? Select the best answer, then select Check My Answer.
Can't shut off the power. It's all the way downstairs. I gotta act now. But if I touch him, I could get shocked too. Oh, what gotta use? A broom. No, too far away. A good push should set him free. It would be quick. Oh, but would it break his grip? Oh, wait, the wires. That's the source. I just need to block them. This'll work.
Select each object to familiarize yourself with some electrical safety controls your employer has put in place. Fuses and circuit breakers are engineering controls that protect wiring and equipment by limiting the amount of current a circuit will carry. They trip or break the circuit when the current flow becomes excessive and unsafe. This prevents the overheating of wires that can melt electrical components or cause fires. Tools are often built with engineering safety controls called equipment ground and double insulation. If a malfunction causes the metal frame of a tool to become energized, the equipment ground provides an alternate path for current to flow through the tool to the ground. You can find an equipment ground on a three-pronged plug. The rounded prong is the ground. Double insulated tools have two layers of non-conductive material on the tool where you typically touch it, like the handle. Another engineering safety control is a ground fault circuit interrupter, GFCI. It's a device that interrupts an electric current when it detects a difference in the amount of current going to and returning from equipment along the circuit conductors. GFCIs are available for electrical panels or in individual electrical outlets. They can also be built in or attached to cords. In some countries, residual current devices, RCDs, are used instead of GFCIs. An arc fault circuit interrupter, or AFCI, sometimes referred to as an arc fault detection device, or AFDD, protects against fires caused by arcing faults. This device shuts off an electric power circuit when it detects an electric arc, preventing potential electrical fires. Some devices are equipped with both a GFCI and an AFCI. Policies and procedures like unplugging unused appliances, using power strips, and never overloading outlets are administrative safety controls designed to promote electrical safety at work. Employees who do dangerous work directly with electricity must always follow strict lockout, tagout procedures, and arc flash safety precautions. Be sure to familiarize yourself with electrical safety policies, procedures, and training requirements at your workplace. Electrical safety training is an administrative control mandated by regulatory agencies or employers to make sure you have the knowledge and skills to stay safe around electricity at work. Employers must provide it, and you must take it and implement what you learn. Only certain qualified and authorized employees who have taken specific training are allowed to work on or around electrical systems. Personal protective equipment, PPE, is safety gear that you wear to minimize exposure to electrical hazards. It can include eye and face protection, head protection, and hand and foot protection. Some examples are safety glasses to keep sparks out of your eyes, insulated tools to protect from electrical shock, and special non-conductive and anti-static footwear. Electrical PPE has specific ratings and uses. Check with your employer to see what you need. It's important to do your part by understanding basic electrical hazards and safe practices, and by using good judgment and caution. Take a look around this job site to identify common electrical safety measures. Select each object to learn more, and use the Hint panel if you get stuck. When you use ladders, be sure to stay at least 10 feet from power lines. Also use non-conductive ladders made of plastic or fiberglass instead of aluminum whenever possible. Before you use a tool or appliance, inspect it. Look for loose outlets or receptacle connections where a plug does not have a tight fit, frayed wires, and wear or damage. Regularly care for, test, and store tools too. Repair or replace broken items right away, because mechanical controls can eventually wear out or fail. Never touch electrical sources to see if they are energized, known as test for dead. If you don't have the proper tools or training to test for dead, get help from someone who does. Be sure to scan for electrical hazards whenever you work. Look for broken fixtures, damaged outlets, and loose wires. Pay attention to emergency exits and make sure there are fire extinguishers and the area is ventilated in case of electrical sparks that could ignite vapors or gases. To keep a safe load on circuits, use power strips with built-in breakers when you have multiple items to plug in. Plug in a GFCI when there isn't one built into the electrical system or tool. Practice good housekeeping and remove clutter in your workspace that could catch fire. Store highly flammable things like gas safely and move anything that's blocking an electrical box. Always handle extension cords properly. Don't tug on them, remove ground prongs, or run cords under rugs that may hide wear and damage. Keep work areas where you're working with electricity dry, especially the floor. Before you dig in the ground, call your local utility location service to identify underground utilities. Here is a practice exercise to test your knowledge. Select and drag the item on the left to its function or definition on the right. When you're finished, select the Check My Answer button to see how you did.
Soren!
You guys still here? Whoa, what happened?
Don't touch any part of the metal wall. Call 911 and go to the breaker panel and shut off the power.
The severity of electrical injuries depends on the amount of electrical current, its path through the body, and the duration of the exposure. Select each object to learn about the injuries that can occur when working with electricity. After reviewing the content, select the X to return to and learn about the remaining images. Superficial or thermal contact burns occur when skin comes in contact with overheated electric equipment, or when clothing is ignited in an electrical incident. If an electrical fire starts, you can also be burned or suffer from smoke inhalation. Electricity flowing through your body can cause serious internal burns and damage. You could experience internal bleeding, tissue destruction, and nerve or muscle damage. These internal injuries may not be immediately apparent to victims or observers, but left untreated, they can result in death. Muscles violently contract when stimulated by excessive amounts of electricity. Violent contractions can damage muscles, tendons, and ligaments, and may even cause broken bones. If the victim is holding an electrocuting object, they might not be able to let go, resulting in prolonged contact with the current. Injury or death may result when pain from shocks, violent muscle contractions, or loss of consciousness cause workers to fall from ladders and scaffolds, or inadvertently strike other objects. Ventricular fibrillation, uneven, uncoordinated pumping of the heart, respiratory arrest, or heart attack may occur with severe electrocution. When a victim suffers from an electrical injury, you have to act quickly. First, check the scene to make sure you are not putting yourself in danger. Then call emergency services, or ask someone else to call for you. Select each object to learn how to respond to electrical injuries. Sometimes, victims who are shocked by electrical current cannot let go of the conductor because of severe muscle contractions. It's critical that you get these victims out of the electrical circuit without delay. If possible, shut off the power by unplugging the cord or turning off the switch or circuit breaker. If that isn't possible, look for an object made of non-conducting material, like a dry wooden board or some plastic PVC pipe, to push the victim away from contact with the electrical source. Do not become a victim by attempting to use any part of your body to break the current unless you have been trained and authorized to do so. If a victim is unconscious, make sure to shut off the power source before providing aid. Do not move the victim. If they have fallen due to the electrical incident, they might have injuries that could be made worse by moving them. Check the victim for regular breathing. If the victim isn't breathing, start CPR by doing chest compressions once you've shut off the power source. Be careful not to move the victim unnecessarily in case they have injuries you could make worse by shifting their body or neck. If you come upon a fire, immediately shut off the power source if possible. Retrieve a type ABC fire extinguisher, one that uses a dry chemical, and start spraying at the base of the fire. Do not use water, because doing so could result in more danger of electrocution. If the fire is already out of control, grab the victim by the pants or shirt collar and drag them out. It is imperative to get both yourself and the victim out of the area immediately. After you do so, make sure emergency support is on the way. Here is a practice exercise to test your knowledge about electrical injuries and responding to them. Read each item at the left. Select true or false for each statement. When you are finished, select Check My Answer to see how you did.
Hey, good to have you back. How are you feeling?
Not the greatest.
Oh, well, we're getting the drywall up now and then the tiling. We've actually made up some time.
Really?
Now we're only,
No, I don't need to know that right now. Let's just keep moving forward.
Oh, sure.
And thank you, Bryce. You saved my life.
Anytime.